Hello, I am Lena Mathew, and I would like to present my artwork titled Visum Beyond the Physical Eye. Electroencephalogram, or EEG, is a non-invasive method for recording electrical brain activity using scalp electrodes. A visual evoked potential, or VEP, can often be seen in the background EEG recorded from the occipital scalp following a flash of light. VEPs are changes in brainwave electrical activity that are created when a visual stimulus is presented to an observer. Visual perception refers to the interpretation of what we take in through our eyes. Optical illusions give us insight into how the brain works. They use patterns, light, and color that create images which can be deceptive to our brains and reveal the mechanisms of perception. Visum is a data-driven audiovisual artwork based on visual evoked potential triggered by optical illusion. VEP objects here are played as an instrument by a user-controlled interface. Visum is created for artistic and educational purposes. The methodology involved here in this artwork includes an EEG device, which is used for brainwave signal acquisition and preprocessing. 8 scalp sensors are used to retrieve brainwave data of each participant. 16 participants were presented with optical illusions while their brainwaves were being recorded from the EEG device. Offline data analysis such as filtering, segmentation, trial averaging was performed in order to extract the VEP data. The multimodal design of Visum includes both the extracted VEP data and user interaction. The sonification of the VEP data uses the granular synthesis method, which breaks up the VEP signal into small grains and recombines them in real time. The user manipulates these grains through parameter controls, such as grain size pitch shifting in the interface that generates a layered sound for each channel of data, which is sent to 8 output channels. The sound objects are spatialized according to the location of the sensors placed on the head of the participants. With the visualization, the data of the sensors placed on the occipital scalp are used in acquiring the VEP data and are mapped to parameters such as 3D image rotation and morphing. The visualization is also synced with the sonification. This is a snapshot of the interface, Visum interface, created in Max MSP Jitter. Here you can see the 8 channels, each having their own parameters, and these 8 channels send information over to Jitter, which visualizes the information. I will conclude here with a brief demo. Here you will be able to hear 8 channels of spatialized sound, and the visualization reflects the brainwave changes caused by a certain stimulus, visual stimulus that was presented to the participant. In addition, the visuals are morphed or transformed according to the degree of fluctuation in the brainwaves, showing the perception of the participant. Visum seeks to externalize visual evoked potentials into sonic and visual sculptures. Essentially, it gives the audience an idea as to how the participant perceived the illusion images that were presented to them.